All right, well, we'll get started. I'm sure a few more people will come jumping in, but value everyone's time. So let's jump into things. My name's Troy Beaver with HalenHardy. I appreciate everyone taking the time out of your day to attend this webinar. Couple housekeeping items. The bags under my eyes are not due to this job and the stress of it. It is due to the fact that I have 1-year-old twins who I have to chase around all the time. So just wanted to get that one out of the way. Everything else associated with the webinar, we have put a link in the chat to our live stream on the YouTube channel. Might be a good idea for you guys to copy that link now. That way, if you run into any technical difficulties with Teams, you can hop into the YouTube link and watch the live stream there. Questions, if you have any questions, please feel free to just throw those into the chat at any time. We'll wait until the end to answer all questions, but so you don't lose your train of thought or forget the question, go ahead, throw it into the chat at any time. We'll address those at the end. Also, there will be an email that goes out following the webinar. In this email, there'll be a link to request your certificate of attendance. So all you need to do is just click that link. We'll get notified. We'll put together a certificate for you so you guys can have the certificate of attendance. I know a lot of people do request those. So keep in mind that'll come out after the webinar. If you don't receive that, feel free to just reach out to my email address will be at the end of this presentation. At the end of this webinar, you can reach out directly to me or to sales@halenhardy.com and we'll get you that. Also, a quick summary of this webinar. A lot of our webinars tend to be regulatory related with a sprinkling of products that could help you meet those regulatory requirements. Overall, they tend to be more of an educational webinar on regulatory requirements, as I mentioned. This one's going to be totally different. This is going to be introducing you to a product and mainly talking about the features and benefits of that particular product. So with that said, let's hop into it. So before we hop in to the Coffer Dam portion that everyone's attending, I know we tend to have a lot of people that this may be their first time attending one of our webinars, somehow got this passed along to them, so they may not know anything about HalenHardy, what it is we do. So I just want to give a brief overview, and then we'll hop into the topic at hand. So HalenHardy, our mission, simplify spill and sediment control. We do that by helping environmental and operations professionals through developing products, especially made for the mobile outdoor workforce, the people working without a roof on their head, over their head on a daily basis. Number two, ensuring products occupy minimal space in your vehicles, equipment, and facilities. We know that most of our customers, due to the fact that they're not working inside of a building, tend to have minimal storage space and place to keep stuff, whether it be working out of their truck, working out of a job trailer, you name it. So we're always looking for ways to make sure our products take up minimal space and designing products that deploy in about half the time and are easier to maintain than conventional options out there on the market, which we'll talk a lot about today. 4 core areas of focus: spill cleanup and containment in the outdoors. That's anything from land-based spills in wet, rainy conditions to containing and cleaning up spills on water or products to put under persistent equipment leaks in the outdoors. We also focus on filtering oily sheen from inside of stormwater inside of secondary containment structures, as well as filtering sheen, silt, and sediment, as well as other contaminants from stormwater runoff around ditches, outfalls, storm drains, catch basins, you name it. And then mainly what we're going to be talking about today, our 4th area, which is one of our products that kind of falls within our dewatering area. So in the chat, it's always good to kind of review these after the fact with our folks to see, how many people really know. Are we educating them? So how many of you have built or seen a coffer dam being built? Feel free to just type yes or no into the chat, give a thumbs up, thumbs down, whatever it may be. We'll kind of review those after the fact and see how many people really knew something about this or didn't, but it's always good feedback for us. All right, so what is a coffer dam? Coffer dam is an enclosure built within a body of water to allow the enclosed area to be pumped out or drained. This pumping creates a dry working area so that the work can be carried out safely. Coffer dams commonly used for construction or repair of bridges, culverts, pipelines, or other infrastructure that travels through or under a body of water. Coffer dams can be made via different methods. I have a few pictures on here. This is a handful of, dozens of different methods. I'm not going to get into every method of coffer dams that there is, but you can see a few here. On the top left, you have, bulk bags or sandbags. On the top right, you have a metal frame with some sort of impermeable tarp material. Bottom left, you have a large tube that is essentially filled with water. So you pump water into that tube, it fills up. Obviously, then it uses the weight of that tube to kind of seal itself to the stream bottom and prevent water from getting into that working area. Bottom right, these tend to be, deeper bodies of water, bigger bodies of water, but what you call sheet piling, which is large sheets of metal that are essentially pounded into the stream bottom at a predetermined depth, creating an impermeable structure. Overall, what you're trying to do when you're building a coffer dam is to stop the water from entering an area, as I mentioned before, that you want to keep dry, so you can do work within it. This could be for the purposes of repairing or building a bridge, crossing underneath a stream for a pipeline, repairing or building a seawall, or even places where crews may need to weld or pour concrete. So a little more in depth on why coffer dams. I like to say safer, drier, faster. Well, there are a lot of times where work needs to be done in an area that's wet, as I already mentioned. It could be a lake, a river, a stream, shoreline, some other body of water. Most of that work can only be accomplished if the area where you're working is dry. You can see in this picture, this is a pretty extreme case, right? You probably have wondered, if you didn't know, how they pour bridge piers. Obviously there's a lot of water, especially when you get over larger bodies of water. So you can see here a kind of a pretty large coffer dam. Not something that we're going to be talking about with our product, but kind of gives you the far end of the spectrum when it comes to coffer dams. But these coffer dams can be used things like I mentioned before: bridge construction, shoreline restoration, boat ramp construction, pipeline construction or inspection, repairing retaining walls or bridge piles, or removing even sunken vessels. Overall, coffer dam takes an otherwise difficult area to do these things due to the fact that it's wet or underwater, and makes it safer, faster to do the work, and drier in order to accomplish that task that otherwise could not have been accomplished. What are the difficulties with some of the traditional styles of coffer dams? There are always some difficulties associated with any style of coffer dam that you're going to use. Here's a few bullet points here. Problem number one, traditional coffer dams, no matter what you're using, require a lot of time and equipment typically. Time to fill and deploy sandbags or install sheet piling or move dirt around. A lot of manpower or equipment to install. You can see in this picture here, this is using bulk bags, right? Some sort of overhead crane structure to drop these things in. You can see all the people standing there. Well, half of them aren't working, but a few of them are. The time to prepare the stream bed, remove all the rocks, make it as flat as possible, right? Because if you're trying to keep the area on the other side of the dam dry, you can't have a lot of structures underneath whatever you're using to create your coffer dam, or else it's just going to cause leaks and water to pour into the area that you're trying to work within. So trying to get all the rocks removed, make that as flat as possible. Time and pumps required to fill the water fill barriers. So I talked about the tube fill barriers earlier. Having pumps there to pump in, depending on the size of them. How long does it take to pump water into those to fill them up? And then there's time to redeploy in case of a blowout, right? Water does not always stay at the same level, right? You could have a change in in weather. You could have a change in release on the upstream side of your dam due to whatever it may be, whether it be snow melt, additional rain, someone releasing more water from a lake at a dam. Either way, once you do that, you have this change in water, which could blow out your traditional coffer dam, therefore having you to take time to rebuild what you already built. Problem two, traditional coffer dams tend to be expensive. Shipping costs to get large bulky sandbags or sheet piling or any of the other equipment to site. Labor costs associated with filling and deploying these things. Equipment costs to lift and install these things. And then after they are lifted and installed, if they blow out, getting those things back to site. Fuel costs associated with keeping pumps or equipment running. Cost of delaying the job days or weeks to set up due to the time that they take to set up, right? So the more time it takes to set up, the more time you are delayed on doing the actual project that you're there to do, which is the things that I mentioned before, building or repairing bridges, putting in pipelines. So the longer it takes to install the cofferdam, obviously the longer the project is delayed. That's time, that's money. And then finally, same thing that I mentioned before with time, but cost of being blown out or washed out and then needing to rebuild that dam. So hopping into what we're here to talk about, the actual product. So to address these difficulties, we have what we call the instant cofferdam, which is made to simplify the process of creating the cofferdam, address the difficulties that I just spoke about. It's lightweight and portable, deploys in minutes with minimal manpower. And I'm going to show you kind of videos and some pictures of all these bullet points, but just kind of running through them real quick right now. Uses just the flow of the water to deploy itself and the weight of the water to anchor itself. You can attach units together to make unlimited lengths. And finally, it's environmentally friendly because it creates limited to zero waste due to the fact that it can be washed and reused over and over again. So how does it work? The concept's actually pretty simple. As I mentioned before, the instant cofferdam uses the flow of the water to deploy itself, and then the weight of the water to anchor itself. So as the flow enters the dam deploys itself, just using the weight of the water to hold it to the stream bottom and then seal itself to the stream banks. What are some of the components of the system? So if you're looking at the dam from the left side of your screen, this is what we call the front of the barrier, or in the case of, I always like to use a flowing stream scenario, the upstream side of the barrier. The bottom fabric is the portion that sits on the stream bottom. The front loops on the front are for anchoring in certain scenarios. I mentioned before, majority of time you don't need to anchor these things. They're using the weight of the water. There are some scenarios like a stagnant water scenario, like a pond or a lake where you may not have flow. So you need to anchor it until you start pumping your dry area and essentially creating the flow. But for the most part, you do not need to anchor. But I like to point out there are front loops on here to anchor in the scenarios that you need to anchor. The gray portions in the middle, we call those the partitions. They are there to ensure that when the dam reaches its maximum height, the dams come in all different heights. The retention fabric, which is the top yellow portion, doesn't just blow over, right? So those retention partitions there, or those partitions there, are made to, just have it rise up to whatever height it is and then keep the dam at that height once it reaches max height. You also have a float across the top of the yellow portion of the dam that helps to rise it up as the water fills the dam. On the downstream side, you have an anti-erosion flap. This is help make sure that, in the event that you do have a change in water, water starts to overtop the dam, it's not mining out behind the dam or digging out behind the dam. As water pours over the top of the dam, what does water do? It's going to start to dig out the stream bottom. So we have what we call, the rear mud flap or the anti-erosion flap there to prevent that from, digging out any holes in the event that you do have water pouring over the top of the dam. Nice thing about these dams, I'll touch on it a little bit more. You're probably wondering, well, if water's pouring over top of the dam, how's it staying in place? They're engineered to stay in place with 33% of their height pouring over the top. So for example, if you have a 30-inch high dam, 10 inches of water can go over top of that dam and it's still going to maintain in place, stay in place until the water recedes. So just to give you that. Finally, there are heavy duty lifting straps on the downstream portion that you can see there, gray or black in color. These are useful when you're removing the dam, but also used to hang up the dam when cleaning or drying it after use. So how does it anchor itself, or how does it stay in place without any physical anchoring required? As I mentioned before, it is the force of the water inside the dam that is holding it in place. Here you'll see it's engineered at a 4-to-1 ratio, and that 4-to-1 ratio is based on the width from the upstream side to the downstream side is the 4, and the retention height of the dam is the 1. For example, a 28-inch high dam is approximately 9 feet from upstream side to downstream side. This means that you get 4 times the vertical thrust compared to the horizontal thrust, which gives it great adherence and not requiring it to be anchored. So how does it work? This video does a pretty good job of showing a pretty simple installation. 39-inch high dam here, 50-foot long. You can see stream about 30 to 35 foot wide. Again, anchoring it just to hold it up on the banks until it gets water into it, but not really anchoring it on the leading edge. You're just submerging that leading edge and standing on it. Some people, we recommend put a row of sandbags along there so you don't have to stand there until it gets water into it. But once it has about, 6 to 8 inches of water in it on a dam that size, it's holding itself in place. So it's just using the weight of the water. The sandbags then, just help a little bit to hold it down until you get that water flowing into it. But you can see in a matter of minutes, you can have a dam deployed. In this case, they're using a diversion around another channel, and then the downstream side is the dry portion that they want to do the work in. But as simple as submerging that upstream bib, as I mentioned before, letting water fill it, letting water anchor it down, and then you can start your pumping on the downstream side to dry it out. In this case, it was a pretty steep slope stream, so the water actually just, used the path of least resistance and headed downstream. So there were no pumping actually required. Sorry, let me. So what about getting these things out of the stream? Just like you use the flow of the water to inflate them when deploying, you're also using the flow of the water to remove them. So I'll show you here real quick. For a single unit, all you're doing is you're going to the opposite bank of where you want to swing to. You start peeling it off of that bank and allowing the water to start to flow around the outside. Once the water starts to flow around the outside, it uses that flow to just swing it to the opposite bank, and then you can pull it out, wash it up, and reuse it. Right? Those lifting straps are on the back end. You can grab hold of those, pull it out. With multiple units, it's not as easy as just going to the opposite bank. So as I mentioned, you attach multiple units together. You can go to those seams and you can start peeling it apart. Peel apart the top seam, you let the water start to recede a little bit, then you go to the stream bottom seam and you start peeling that apart. Now it's using the flow of the water just like a single unit would to swing the units apart and allow the water to recede. So the units will swing, again, let the water recede, then you can just pull them out, as I mentioned before, wash them up and reuse them. So it's pretty simple. There's no difficulty to it. You're just allowing to use the flow of the water just like you use the flow of the water to inflate it. Let me go back here. Storage space and transportation costs. I think this picture does a pretty good job of explaining storage space, transportation costs. So on the right side is a 28-inch high by 25-foot dam. That would be the equivalent of about 550 sandbags if you were trying to build that same cofferdam with sandbags. So I haven't done the calculation on, you saw that first dam in the first video, which was 39-inch by 50 feet high. I could probably do those calculations, but you're probably looking at 5 to 6 times that amount to create that same dam. So you can imagine the amount of storage space, transportation costs, and everything else associated with trying to get that stuff on site and deploy it. As I mentioned, unlimited length. So these units can be attached together. On the left there is a 30-foot units attached together. So 90 feet coming in 3 30-foot units. So attaching them together, this makes it nice because, you know, if you have one project where you need, it's a smaller stream and you just need a single unit, you're not trying to manhandle a 90-foot unit, right? But if you get into a larger project where you do need 90 feet, now you can take multiple units, attach them together to make that. Takes minutes to attach these things together once you get good at it, you know, a couple times, and it becomes pretty simple to attach the units together. All the attaching is very heavy duty Velcro. It's been tested, third party tested that it's going to hold up under the obviously pressure of the water that's going to be created on those dams based on the height of dam you have. So we've done pretty much every height of dam we have in some pretty large bodies of water, and we've never had a single unit fail at the attachment point. Another key attribute, quickly access remote areas, right? So now you saw this is actually the picture where you saw the firefighter carrying the dam. This is the same size dam that you would have there, 28-inch high, 25-foot long. So, you know, about a 10 to 15-foot wide stream you can see here. Very remote area where this needed to be dammed up. So down over steep banks, would have been very difficult to get any type of equipment in there, difficult to get, you know, any type of materials really in there to effectively build a dam in a cost-effective and timely manner. This took minutes to, you know, you can roll these things, they come rolled up, you can roll it down over a steep bank, you know, get down there, unravel it, stretch it out across the stream in minutes, and you have the water dammed up. Flexibility. Here you can see, due to the material that it's made out of, it's a PVC coated polyester. It is a very flexible material. It will conform around pretty much anything you can think of. So for example, here you're looking at a corrugated pipe, right? Their way of bypassing the water through their dry area where they wanted to work was a corrugated pipe. The dam itself can go up and over top of this. You can tuck it in underneath the corrugated pipe, essentially creating a pretty fine seal around that. Water can then flow through the corrugated pipe. You can also see here, I'll show you in the next picture. This one's not as close up, but you can see it's going up the walls of this this stream, right? They're concrete walls, 90 degrees straight up. So it's flexible enough to go straight up the walls. So you can anchor it at the top of those walls, along the side of those walls, but flexible enough to go up. The other thing that I mentioned before with traditional cofferdams, when you're building them, you have to get the stream bottom pretty smooth, right? You don't want any rocks or any type of objects underneath traditional cofferdams, because all they do is create void space where water can travel through, essentially getting into your dry area and defeating the purpose. With this, really all you need to do is that first 12 to 18 inches of where the bib lays on the stream bottom, that's where it's creating its seal. So I mentioned before, a 28-inch high dam is about 9 feet from upstream side to downstream side. You're really only needing to clear out and get as best as possible that first 12 to 18 inches, because that's where it's creating the seal. Any large rocks, debris, anything else under the remaining 8 to 8.5 feet, or 7.5 to 8 feet, of that dam is fine because it's conforming around it. As water enters that dam, it's using the weight of that water to conform it and seal itself better. And the majority of your seal is happening within that first 12 to 18 inches. So again, time savings, money savings from a standpoint due to its flexibility and not having to remove all that stuff before installing the dam. Here's another good picture showing, culvert repair, right? Flexibility of the dam going up the sides of the wall. You can see just anchoring it into the wall of the culvert there. In the event that you can get actually to the top of the wall, if it's not a fully enclosed culvert, you can just lay it up over the top and, put some weight on it to hold it there. In this case, they're obviously inside a culvert, so they are drilling in and putting anchoring points in, but where it would be difficult to get a piece of equipment in, get different types of materials in there to build a traditional cofferdam. Here's a good picture of it in a very difficult area, but the flexibility of it to go up walls that are approximately 90 degrees straight up. So from a time savings aspect, I'm comparing what it would take to build a 25-foot long by 28-inch high dam. So, let's talk, when do you put in typically our 28-inch high by 25-foot long? It's approximately a 10 to 15-foot wide stream, right? Yeah, you need excess length to go up on each bank to make sure you're above the height of the dam. So with a traditional cofferdam, you're looking at a minimum of about 6 hours to mobilize, deploy, and tear down in a stream about that width with a height of 28 inches of dam. With the instant cofferdam, you're looking at under an hour to mobilize, deploy, and tear down. The majority of that time actually isn't just your mobilization time. Obviously, due to their size, you're not going to need a trailer or flatbed, so they can easily be stored on site or even brought in a pickup truck. Not to mention, in the event that there is a heavy rain event, the dam can actually overtop, as I mentioned before, by about 33% of its height. So it can just remain in place. Unlike a traditional cofferdam, which would probably blow out and need to be completely rebuilt. If you're more comfortable pulling the dam out and you don't want to watch it overtop by water and take my word for it, again, that just takes minutes to take the dam out and then, again, minutes to redeploy. So you're not talking a whole lot of time in the event that you have some significant changes in weather. As far as saving money, looking at that same 25-foot by 28-inch high dam comparison, cost savings are pretty significant just on the first initial install, right? So on the front end, you're looking at approximately $5,500 for the equipment, tools, labor, and disposal costs associated with a traditional cofferdam. The majority of that cost is tied up in the time and labor it takes to build and tear down the dam. With the instant cofferdam, you're looking at about a cost of $3,100. The biggest thing to note is these dams are able to be reused over and over, whereas all the items used on a traditional cofferdam are single-use items. Not to mention limited transportation costs, no equipment costs, and no disposal costs associated with the instant cofferdam. This chart also doesn't take into account the cost of having to delay the start of the job due to waiting on materials. So sometimes you're waiting days, if not weeks, to have the materials delivered to site and installed. At that point, you could have installed our cofferdam and taken it out a few dozen times if you needed to. So accessories. I have a few accessories. The main one that I'm going to talk about today is the diverter attachment, right? When installing any type of cofferdam, ours included, you need to figure out a way to divert the water, for lack of a better term, right? And this can be done in a plethora of different ways, right? As water fills behind the dam, eventually the water is going to reach the height of the dam and pour over the top, therefore defeating the purpose of having a dry area on the downstream side of your dam. So you need to figure out a way to divert it. How do you do that? I showed you a picture of the corrugated pipe with the cofferdam going around it, right? Water can flow through that corrugated pipe, at a predetermined size, right, based on your flow rates of water that you need to make sure that that pipe can keep up with your flows. water flows through it, goes to the downstream side of your dry work area. Another way is, you saw before the first video I showed you, there was a trench or a bypass stream tributary that the water could essentially go around the dry work area in. So that's able to keep up with the flows. The water can continue downstream around your dry area. You do your work there. Another way, probably the most common that I run into, is pumps, right? So you have a litany of pumps on the upstream side that are sized to keep up with whatever your flow rates are. Your discharge of your pumps, the hoses, the pipes discharge below your dry work area. So another way, you just keep the pumps running. Can be a costly way to do it, but it is a common way that we see. You know, if a pump fails, you can always just bring in another pump. If you didn't size your pipe appropriately, you're corrugated, you have your dam installed, and you have a significant change in water events or flow events, it's tough to install another pipe once you have your pipes installed, but it's simple to bring in an additional pump. So we do see pumps a lot as your bypass way. This is one of our accessories that we have. We call it the diverter attachment. This attaches to the top of your dam. So you have a hard plastic piece here. We're just showing small stream. Here we didn't do any stream prep work. This was just to show the accessory, the diverter attachment. So don't mind the little bit of water that is coming through on the downstream side. We didn't remove any rocks. We just wanted to show the diverter attachment and how it works. So really water filling the dam. So you can see hard plastic piece, and then you have a flexible pipe that attaches to the end of the hard plastic piece. Hard plastic piece or the diverter attachment will attach directly to the top of the flexible dam. So now as water rises, water can then flow through that diverter attachment and therefore keep the water from overtopping the dam. It goes through the flexible pipe and discharges below your dry work area. Same as with the dams, there's an unlimited length with the discharge pipe. So the initial is a 75-foot section, and then you can attach sections to that to run unlimited lengths. Each one of the diverter attachments flows 1,440 gallons a minute. So this isn't for every scenario, right? This is you have to do flow calculations and make sure that this can keep up with your flows, but it is, especially for smaller, lower flow scenarios, smaller streams, it's a great alternative to having to keep pumps running or anything like that. So each diverter attachment flows 1,440 gallons a minute, as I mentioned before, and you can attach 2 units to each dam. So you're essentially getting about 2,800 gallons per minute that you can bypass through the diverter attachments past your dry work area. So I'm going to talk a little bit about installation methods, just so you guys can wrap your heads around, you know, some of the different installation methods that we run into. I'm talking about the most common ones here, and how showing you some pictures of these being deployed in those scenarios. So the first is a perpendicular on a steep slope. So perpendicular, I'm talking about how the dam is to the flow of the stream. So obviously perpendicular to the flow, so straight across from stream bank to stream bank. And this is a steep slope stream. So what I mean by that is, you know, the slope from upstream side to downstream side of the dam is fairly steep. So you can see here, you install a dam on the upstream side, and then whatever your bypass method may be. In this case, corrugated pipe, could be our diverter attachment, could be pumps. But either way, the slope is so steep with the stream that when that water discharges on the downstream side of whatever you're using to bypass the water, it's not coming back up towards your dam, right? Because this slope of the stream carries the water downstream away from your dry work area. So that's scenario 1. Scenario 2, this is a perpendicular on a shallow slope, right? So the stream is not as steep as the one you saw previously, right? So when your water discharges through whatever your diversion method is, in this picture here, you're well, in the drawing you're seeing a corrugated pipe. In the picture you're seeing here, you're not seeing the actual pumps, but on the right side of this picture, is the upstream side. So you can barely see the corner. Couldn't fit the full picture in here, but you're barely seeing the corner of the upstream side of this dam here. The pumps are pumping from that side, and the pipes you're not seeing are running essentially behind us right now, and then discharging on the left side of your screen, so on the downstream side. This is a shallow slope stream. So that water that was discharging from these pumps was wanting to come back upstream towards the dry area. So you can see all we did here on the left side, you can see the left dam. That's actually the downstream side. We just installed another dam reverse. Right? So now the water that's trying to flow back upstream due to the slope not being very steep is essentially, it's deploying the dam in the reverse direction. So you got natural flow on the right side, deploying the dam on the upstream side, and you got the bypass flow that's trying to come back upstream on the left-hand side of your picture, deploying the downstream dam. So all we're doing is just reversing how you're deploying the dam and using that flow from the bypass water to deploy that dam, preventing it from coming back into your dry area. So you can see here, now they're able to pump that area dry, not worry about water coming from the upstream side, which is the most common, or the downstream side in this scenario due to the slope of the stream. What about another one, bridge repair work or some sort of in-water structure that you're trying to repair? You can see here, just using the bridge pier as your flow around, right? So your flow is coming from essentially, you know, this side of the bridge, right, that we're on. Looking at this picture, you're diverting the water around the bridge pier so it can continue downstream, and you're creating your dry work area underneath the bridge there. This would be, again, more of a steep slope scenario where the water will continue downstream. I didn't put a picture in here, but imagine if it was a slow slope or a not so steep slope, a shallow slope. You would just continue essentially creating a U shape with that dam going around the bridge pier and then back to the same bank that you started on below your bridge. So as water flowed around, if it did want to, for whatever reason, make its way back up into your dry area, you would just continue around, which is essentially shown here. You know, here we have no bridge pier, but we're creating a U-shape installation, right? So again, you don't need to dam up the entire stream. You may be doing some sort of you know, wall repair, some sort of work along a stream bank or a river bank where you don't need to dam up the whole stream. You don't want to have to worry about pumping water completely around a larger stream that you're damming up. In this case, you're just, you know, damming up a portion, creating a U shape. So you're coming off your upstream bank, you're going out into the stream however far you need to create the dry work area that you need. You're going downstream parallel to the flow, and then you're coming back to your stream bank that you started on. And water will continue to just flow around the dam as you pump your area dry and work within that dry area. All right, final thing. That's pretty much, there's a lot of technical stuff I could get into on these coffer dams. We have a whole guide that addresses technical questions. You know, I can answer questions if you have them in the chat. I don't want to bore you with all the technical details of exactly how do you install in every scenario. I just wanted to kind of give you a broad overview of the technology itself, how it works. The one final thing I want to touch on is just the other dam that we have to address a totally separate issue, but works very similar. This is what we call our instant underflow dam. So the coffer dam for creating a dry work area in stream. The instant underflow dam, this is, we tend to have a lot of environmental professionals on our webinars just due to the fact that majority of our products that we make address environmental issues. This one falls more in line with the environmental issues. So in the event that a oil or fuel hydrocarbon type spill reaches a body of water, a flowing body of water. This is a version of dam that will quickly dam up the stream. And I like to talk about it because it falls in line with the coffer dam. So the video does a pretty good job of showing exactly how this works. So in the event that you have a spill, very similar to the coffer dam, it's going to deploy the same way, right? You're going to go up on each bank above whatever height of dam you have. you're going to submerge the leading edge. You're going to either stand on it, put rocks on it, put a couple sandbags on it until it gets about a few inches of water in it to start to weigh itself down. So again, here we were just using some rocks. Either way, you're getting a few things to anchor it until it gets the water in it. Once it has the water in it, it's using the weight of the water to anchor itself. So you can imagine most oils and fuels will float on top of the water, right? So when floating oils or fuels are coming into this dam, we're just putting some sort of absorbent boom that can start to absorb that product, that spilled product, to protect the dam. But the other thing that's going to happen is, as with the Coffer Dam, water's going to fill this dam, and the oil that's floating on top is eventually going to want to breach the top of the dam. In this scenario, you're looking at about a 5-minute time lapse. So you can see the water fill in the dam. Imagine those leaves are your floating oils that are coming down. You just stopped them. Now the water's filling the dam, but you don't want that oil to breach the top of the dam and continue downstream. There's underflow holes built into the downstream side of this version of the dam, unlike the Coffer Dam, that allow the clean water that's underneath your floating oils on the upstream side to continue downstream while you do your cleanup efforts on the upstream side. So just another version that I always like to show. When I did my underflow webinar presentation, I showed a little bit on the Coffer Dam. Now I'm doing the Coffer Dam. I always like to mention the underflow. So just wanted to quickly show that. May not apply to most of you, may apply to some of you, but it never hurts to show that. All right, so with that said, let me, if I can pull up chat here and see if there's any questions. Going through here. All right, questions. Not a question, statement. You can also isolate a ship that needs to be worked on. Correct. One thing that I didn't talk about here. So max height that we go up to on these versions of the Coffer Dam is 60 inches. So we're not getting into those scenarios where I showed you the sheet piling in the middle of the river. Reason being, obviously, you can see when you're deploying these, you need to be actually standing in the body of water to deploy it, right? So for safety purposes, 60 inches is about the max height. That typically starts you in somewhere around, 2 to 2 feet of flowing water. So you can deploy it, get it in there, let it get in. Isolating ships, that's correct. I mean, if you have something that's closer to shallow water, under 60 inches, we could definitely do something like isolating a ship with a traditional Coffer Dam for sure. Those big sheet pilings or other types of traditional Coffer Dam methods. Our method, probably not as much. YouTube link, Mark, looks like they got you. Maximum heights, all right, Jim, thank you. I just addressed that. So maximum height, we go up to 60 inch. So again, this is more for your shallower body of water, not like, doesn't have to be a trickle, but definitely shallower bodies of water, but it's an alternative to traditional methods for those shallower bodies of water. What's the best way to install on a rocky bottom stream? Do we need to remove all the rocks? I kind of touched on that a little bit. Again, the seal with this dam is happening within that first 12 to 18 inches on the upstream side where it lays on the stream bottom. That's where you're creating your seal. So actually any other rocks sitting underneath the downstream portion after you get past that first 12 to 18 inches just actually gives it something, I like to say, friction, more something to grip onto. So removing those, I don't even recommend unless you got some extremely large boulder that's just making the install, difficult. But, standard size rocks, boulders, things like that. No, just let that portion kind of go over top of it. It's going to conform around it due to the weight of the water. You'll be fine. Just trying to get that first 12 to 18 inches as clear as possible, and then the seal creates itself. So great questions. The other thing I wanted to talk on, then we had another question come in. So with the seal, right, as water fills the dam, it's obviously going to start to rise up higher, which means it's going to go up higher on each bank. That's another place for water to potentially get into your dry area, right, or leak around. So banks, stream banks, clearing those off as best as possible. You don't want a large overhanging tree right where you're installing your dam. You don't want a large undercut bank right where you're trying to install your dam. There's ways to address these things for sure, and you can still install your dam there. But obviously, you're trying to find, the best places possible where there's the least amount of obstructions, especially with that first 12 to 18 inches on the upstream side. So if you have high grass, branches, twigs, rocks, even on the stream bank, try to get those cleared out, smoothed out as best as possible in that first 12 to 18 inches. Try to avoid trees, try to avoid extreme undercuts. If you can't avoid undercut banks, which I know is sometimes a difficulty, maybe packing a couple sandbags underneath or back into those undercuts prior to installing the dam. And then when you install the dam, push it back in there and maybe put a couple sandbags to kind of pack it back in there. That limits the infiltration. That helps prevent as much infiltration as possible. So stream banks is another area that you have to be aware of when installing ours or any coffer dam, obviously, because water is always going to follow the path of least resistance. So do you offer a field training class? Depends on where you're at. Yes, the answer to the question is yes. We've traveled pretty much all of North America training on either of the products I showed you today, the coffer dam or the underflow dam. So yes, we can do that. Certifications, we don't offer certifications as far as government agencies come. We haven't run into that per se. As far as needing certifications, typically where the question comes into play, especially in the States, is kind of every state, has different regulations based on what can be installed in a body of water, right? When it comes to coffer dams. Nice thing about ours is we're not disturbing or minimal disturbance of any of the stream bottom or within the stream banks when installing our dam. Compared to pretty much any other system, there's some sort of disturbance happening. So the nice thing about ours is we're not doing any disturbance. Most folks we have, in all the years we've been doing it, very few people have come up to us and said, no, you can't do this. Sometimes you run into folks where you need to do a demo or show them how it works or get someone in contact with them that's kind of a peer-to-peer that has used the dam or approved the dam and say, here's where we're using it. But I have not done any certifications that government agencies would expect for when installing these. And that tends to be fairly similar with temporary cofferdam systems that we've run into. I can't answer every state. I can't answer every country on that, but in the years we've been doing it, we haven't run into any requirements for certifications to install our dam. Can these flow through dams be used in high flow rivers? I'm assuming the question, Scott, is the high flow rivers flow through dams. I'm assuming you're talking about the underflow, but either way, we could talk about both. The coffer dam with the diverter attachment that goes on top, as I mentioned before, you're talking 1,440 gallons a minute. 2 of those can be attached to a dam. So you're talking approximately a little over 2,800 gallons a minute, right? There's going to be some calculations of flows that need to be done to make sure that those can keep up with it. I can get you the exact calculations on our underflow holes. Obviously, with the spill underflow dam, each hole is and don't quote me on this, I can get the exact numbers if you need them, 4.5 inch diameter hole. So the flow through those, typically we're talking not high flow scenarios, but we've been in high flow scenarios and we've had every single underflow hole open and the dam has worked. These are typically scenarios where you would be installing a traditional underflow dam, which are ditches, smaller streams, where the flows are lower. And the reason for that is if you have lower flows, you need to install a dam to create depth of water to therefore clean up the oil. If there's no depth of water in the stream, then the oil, there's no way to really clean up the oil because it's traveling underneath rocks, it's traveling between rocks, debris, you name it. So what you do is you dam up a shallower stream to create depth of water. You get the oil to flow to the top, and then you can do your cleanup efforts. So typically where we're installing an underflow dam is lower flow, shallower waters for the purposes that I just mentioned. Using this in the environmental field would fuel oil break down the material of the dam. No, I have all the chemical compatibilities. This is a highly chemical resistant material. It's a PVC coated polyester, as I mentioned before, made exactly for those types of scenarios. We make our actual secondary containment products out of the same material, PVC coated polyester. Highly fuel resistant. There obviously are certain chemicals that may break it down a little sooner than others. But as you saw in the video that I showed you with the underflow dam, we also put an absorbent boom on the upstream side, right? You can put an absorbent boom, you can put a containment boom, you can put any type of method on the upstream side that would divert it and deflect it away from your dam to a collection point where you can start collecting that oil or fuel and therefore extending the longevity of your dam. I always recommend that, but it's not absolutely necessary. If all you have is your dam and you just want to stop it and you want to prevent the oil or fuel from continuing downstream, just install the dam. It's highly chemical resistant, especially to oils and fuels, which it's meant for, so you'll be good there. Do you have a PhD credit form? Yep. So we have a certificate that we will send out. I'm not, to be honest with you, George, I don't even know what a PDH credit form is, but we will send you a certificate. We'll send an email out after the fact, and we will get you a certificate of attendance for this. Whether that's a PDH credit form, I apologize for not knowing that. Karen's not on today. Karen is our regulatory expert. She would probably know exactly what you're talking about, and she would give an answer to you, but she had another webinar that she's doing. So I am not that technical expert when it comes to credits, but we will get you a certificate. So yes. Same with Kevin. George, yes. All right, great. There, Karen is on. Thank you, Karen. Professional development hours. We got it. So yes, we will get you a certificate. Thank you. And Karen, thanks for hopping on and helping me out there. Anything else? Well, hopefully, you know, we had till 11 o'clock. I appreciate everyone. Thank you again for attending. Again, we will send out an email with that certificate request. Just click the link. We'll get it out to you. We also have an email probably going out within the next few days with a couple just little things that we like to send out that may help you with whatever topic we talk about on our webinar. So we'll get that put together and get it out to you here within the next week or so. So keep an eye out for that and keep an eye out for any future webinars that we do. Again, thank you for everyone for attending. Appreciate you guys taking the time. We know you have plenty of other things to be doing, so thank you for attending our webinar.